Hi, in this lesson, we'll learn about cryptography and explore a historical cipher called the Caesar cipher. The internet is an open place. When you're sending digital information over the internet, the information you are sending can be read by anyone. Still, we share a lot of sensitive information over the internet. We're sending out our credit card information, our health records, bank accounts, and passwords. All of this information can be picked up by someone who's listening. So we need a way to keep this information secret when we're sending it over the internet. This is where cryptography comes in. Cryptography is the practice of encrypting information so only authorized people can read it. Cryptography uses encryption, which is the process of converting information into an unreadable form. This helps to keep it secure from unauthorized access. Only those with verified authority, such as a password or a secret key, should be able to unscramble the message and read the original information. It's like putting your message in a secret language that only those who know the code can understand. Let's go over some of the words that are used when talking about encryption. You start with a readable message. This is called plain text. Anyone can read it easily. Then you encrypt the message using a key. A key is a value or variable that is used during encryption. The message cannot be decrypted or unscrambled without knowing this key. The message that results from encryption is called ciphertext. This cannot be read unless you decrypt it using the key. If you use the encryption and key to change plain text to ciphertext, this is called encryption. If you reverse the process and go from ciphertext to plain text, it's called decryption. And you can only do this if you know the key. There are many different career opportunities in the field of cryptology. A cryptographer uses math and physics to come up with new ways to encrypt data. They must be sure that their encryption techniques are strong enough to prevent someone from decrypting the information. A cryptanalyst tests encryption methods by attempting to break in and decrypt them. They may work with a cryptographer and attempt to break their encryption. If they can get through, then the encryption must be made stronger. Cryptanalysts can also help out in criminal investigations in ways such as bypassing security features and breaking into a mobile phone of a criminal to find evidence. Cryptology is the study of both encryption and decryption, so a cryptologist would work on creating encryption methods as well as trying to break these methods. Let's talk about the history of cryptography. A classic example of a historical cipher is the Caesar cipher. Around 100 BC, Julius Caesar was known to use a form of encryption to convey secret messages to his army generals posted at the warfront. Each letter of the alphabet is shifted by a key value. Since there are 26 letters in the alphabet, there are 26 keys. Here, we can see that a key of 3 would shift all letters over 3 spaces. This would replace all A's with D's, and replace all B's with E's, and so forth. Let's take a closer look. This is a Caesar cipher wheel. The ring in the middle is the original message, or the plain text, and the purple ring on the outside is the ciphertext. If we choose a key of 3, we can see that all A's are now D's, and all B's are now E's. Let's try a different key. Let's try 20. Now we see that all A's turn into U's and all B's turn into V's. And we can use the key 26. That just brings us back to the beginning. A's are now A's again and B's are now B's again. The Caesar cipher is classified as a substitution cipher. This means that each character or symbol of the plain text is substituted by another character to form the ciphertext. If you know the key for each character, such as B's are substituted with E's, well then you would just reverse that process to decrypt the code back to the original message and change all E's back to B's. As you might have guessed already, this isn't a really strong cipher. There are only 26 possible keys. A computer could do this in milliseconds, and really a human could break this very easily as well by using what is called brute force or trial and error. There's only 26 possible keys to try. Instead of trying all 26 keys, we could look at the letter frequency as well. Certain letters of the English alphabet are more common than others, like the letter E. If you took the letter frequency analysis of a Caesar ciphertext, chances are that the letter that shows up the most would most likely be the letter E in plaintext. So you can just figure out the key or the shift by looking at that one letter. This is where Vigenère, a 16th century cryptographer, took the Caesar cipher up a notch. He used the cipher, but he decided to use a different shift for each letter. The Vigenère cipher consists of several Caesar ciphers in sequence with different shift values based on a keyword. Let's take a look. Let's use a keyword of dog. Now, the letter A would be a shift of 0, B is a shift of 1, C is a shift of 2. So this makes D a shift of 3. The same process gives us a shift of 14 for O and a shift of 6 for G. The first letter of the plain text would be encrypted using a shift of 3. The second letter would be encrypted using a shift of 14, and the third letter would be encrypted using a shift of 6. Then it would just start over and continue this pattern of 3, 14, 6 for the entire message. Let's look at an example. The first letter is shifted 3 times to the letter D. The second letter is then shifted 14 times to the letter H. The next letter is shifted 6 times to the letter Z. Now here you may notice that the plain text letter T is encrypted to 2 different letters using this method. Well, that will definitely help hide the message. We continue this pattern of 3, 14, 6 until we get the full ciphertext. Because the shift changes each time, you now can't break this cipher using brute force. The shift is based on a keyword, and that keyword can be any length, so there are infinite possibilities. Letter frequency also won't work because the same letter could be shifted in more than one way. Since common letters are encrypted as different ciphertext letters at different points, finding the most common ciphertext wouldn't work in this case. Cryptography has obviously evolved since the time of Caesar and Vigenère. Caesar only had a choice of 26 different keys. Cryptography today measures keys in bits. A bit is like a place value. Each bit or place value can be a 0 or a 1. For example, if you use a 10-bit key, then your key could be 10 zeros, it could be 10 ones, or it could be any combination of zeros and ones. The number of different possibilities can be represented by 2 to the n power. So for a 10-bit key, this is 2 to the 10th power, or 1,024 different possible keys. Well, that's much better than 26. In today's encryption, it's common for a key length to use 128 or 256 bits. So how many possibilities do you suppose a 256-bit key has? Well, this many possible combinations. And I'm not going to try to read that out. It's a lot of commas. There are also stronger encryption algorithms that use a key length up to 4,000 bits. So you can imagine how much bigger this number would be for those keys. While this may seem safe for now, computing power continues to get better and faster, so we do need to continue thinking of ways to keep our data safe on the internet. Cryptologists are already starting to work with encryption techniques that use quantum computing. Instead of using mathematical algorithms, a quantum computer encodes information in particles, like photons and electrons. Quantum mechanics allows particles to be more than just on or off, or 1 or 0. These particles can exist in a superposition of these two states, so like half on or half off. As you can imagine, this would provide a much larger number of possible combinations. All right, now it's your turn to explore. Have fun!